Let's see what we mean by water demand. Water demand is the measure of the total amount of water used by the customers within the water system. That means water demand is the measure of total amount of water which is used by the customer or consumer. There are several things that can influence the amount of water demand of your system. One of the most important jobs of a water system is to continually meet this demand without interruption. That means to supply water continuously without any interruption. Okay, let's see what are the factors that affect rate of demand of water. There are various factors. Number one, climatic conditions. What happen in different types of climatic condition? In hot weather, uh, the rate of demand is increases because consumer use more water than winter session in hot weather. So climatic condition is one of the factor that affect rate of demand of water. Number two, cost of water. When the cost of water is high, then the rate of demand is low because consumer always uh, try to resume their cost so that there is no more expense. Then number three, distribution pressure. Rate of demand is also depends on distribution pressure. When the pressure is more, then the rate of demand is high. Number four, habits of population. It's also affect the rate of demand. There are a lot of people who always try to spend more water for their different types of purposes. It may be domestic or civic or industrial purposes. So it's mainly depends on habits of population. Number five, industries. Small industries need small quantity of water, and then if the industry is big, then what happen? The rate of demand is high. Policy of the metering. It's also important factor. When you provide metering system in water supply system, then the mm, uh, uses of water is to be uh, restricted. That means restricted means uh, most of the time you will try to spend uh, your water as much as your using purposes so that the price is always being low, because the more you use the water, the more will be the price. Number seven, quality of water. If the quality of water is better, then the rate of demand is to be high, because consumer always that means consumers requirement is good water which is good for quality. Suppose it is to be free from any types of dirt or free from heavy metals such as arsenic, lead, etc. Sewerage is the wastewater. It also affect the rate of demand. Size of city. Size of city is also an important factor which affect the rate of demand, because larger city require more water, whereas smaller city requires less water. System of supply. It's also affect water demand. Which types of water supply system is to be provide for water to the consumer. Now, what are the various purposes for which water is required? Because water is required in many purposes. Mainly, major things are uh, domestic purposes, civic or public purposes, industrial purposes, business or trade purposes, and the last one is loss and waste purposes. What are the domestic purpose for which water is required? That means water is required in many domestic purposes. Number one, drinking. Every day we drink potable and palatable water, which is free from uh, germs, dirt, etc. So, domestic purposes we use drinking water. Second one is cooking. Each and every day we take water for our cooking purposes. So it's also required for domestic purposes. Bathing is the same thing. We always try to take shower or bath each and every day. So water is required for these purposes. Washing hand and face, and then number five, household sanitary purposes. Sanitary purposes means to wash clothes, floors, utensils, etc. And last one is private gardening and irrigation. Many of us uh, try to uh, take different types of gardening and irrigation, and for this reason they use water. Per capita water consumption, that means which purposes a man use water: drinking purposes, cooking and preparation of food, bathing, cleaning, washing and personal hygiene, watering of vegetables and gardens, watering of livestock. Livestock means uh, the animals which are taking care in our house, such as cow, it may be dog, etc. Sanitation, and also for sanitation purposes. In the rural areas of Bangladesh, the water requirements for various purposes has been estimated as follow. Drinking purposes, we take 2 or 3 liter. LPCD means liter per capita per day. Washing clothes, 8 to 10 LPCD. Washing utensils, 6 to 8. For cooking, 3 to 5. Bathing, 14 to 20. And for other purposes, 9 to 14 LPCD. Now, water quantity. Water is required by a community for domestic and other purposes. The estimation of quantity of water required by a community is important for the design of a water supply system. Now, if you want to estimate the quantity of water, then at first you have to find out the population, which uh, uh, population use this water for their daily uses. So at first you have to find out population. So population forecastation is the main thing here. The following 7 methods are generally used for predicting future population. uh, Sorry, there are 9 methods here generally used for predicting future population: arithmetical increase method, geometrical increase method, incremental increase method, graphical method, comparative method, zoning increase method, ratio and correlation method, growth composition analysis method, and the last one is logistic curve method. That means by this method we can forecast about our future population. Let's see a problem which is related to population forecastation. The census record of a city shows population as follows. That means present population is 50,000 before one decade. That means 10 years ago. One decade means 10 years. 47,100. Before two decades, it was 43,500. Before three decades, 41,000. Now, work out the probable population after 1, 2, and 3 decades by using arithmetical increase method and geometric increase method. Let's see the solution of problem 1. The average increase of population successive decades up to present is worked out as follows. Present and first decade, that means the number of population increases uh, uh, from first decade to present 50,000 minus 47,100, that is 2,900. And for first and second decade you can easily find out by subtracting from one decade minus two decade, then 3,600, and also for second and third decades 2,500. Now if you sum up these three things, then the total would be 9,000. Now average increase per decade, if we divide this value by 3, then you can find out average increase per decade. So it was 3,000. The population after each successive future decade is obtained by adding this average as follows. Population after one decade, that means present population is 50,000. So population after one decade, that means from present to after one decade, that means 10 years later. So 50,000 plus this 3,000, 53,000. Population after two decades, 53,000 plus 300, 3,000 is equals to 56,000. Population after three decades is equals to 56,000 plus 3,000 is equals to 59,000. Here we have solved this thing by normal average increase of population, considering average increase of population. Now we see uh, what would be the population after 1, 2, and 3 decades by arithmetical increase method and geometric increase method. By arithmetical average, the present increase in population from decade to decade is worked out as follows. That means present and first, the number of population increased 50,000 minus 47,100 divided by 47,100 multiplied with 100. That means the percentage due to present and first decade, it is 6.16, and the same for first and second decade and second and third. Now average percentage is to be, if we sum up 6.16 plus 8.28 plus 6.10, then we get 20.54. We can divide it by 3 and we can easily get 6.887, which is average percentage. Now population after one decade, that means if the present population is 50,000, now what would be the population after one decade? That means after 10 years. So if the population growth rate is 7%, then we can easily find out that 50,000 plus 50,000 multiplied with 7%, that means 0.077, 7 divided by 100. So we get 50,500. And the same for population after two decades and three decades. And let's see by geometric average. The average growth rate is obtained by the geometric average as follows. The formula to find out the average percentage, geometric average, to find out the geometric average is equals to A is equals to n root over A1 multiply with A2 into A3. A1 means 6.16, A2 means 8.28, and A3 means 6.10, and we get 6.78, which is near about 7. Now, population after one decade is 50,000 plus 50,000 multiplied with 7%, same as before. Now, problem 2. The population of a town was 1,80,000 in 1980 and 2,20,000 in 1990. What will the population be in 2000? So, in 1980, the number of population was 1,80,000, and in 1990 it was 2,20,000. So you have to find out the number of population in 2000. Okay. At first, let's see the formula to find out the future population. We know that PF is equals to PP multiply with 1 plus R to the power n. Now we introduce the symbol. PF means future population, PP means present population, N is equals to number of years, and R is equals to rate of population growth. Now, first we have to find out the rate of growth rate. So, we have already find out the population of 1980 and 1990, and the value of year is equals to 10. That means the gap from 1980 to 1990 is 10 years. So from this value we can easily find out the value of R, that means growth rate. Here growth rate is equals to 0.0203. Now we have to find out the population for 2000. Now the population for 2000 is equals to population of 1990 multiply with 1 plus 0.0203 to the power 10, because from 1990 to 2000 is 10 years gap. So the number of year is to be 10 here, and the growth rate is 0.0203, and the population for 2000 is equals to 2,68,969, and is the absolute result. Okay, let's see problem number 3. The population of a community in 1950, 1960, 1970, 1980 and 1990 was 200, 230, 280, 350 and 450 respectively. Estimate the population of the community in the year 2000 and 2010. Also estimate the quantity of water in the year 2000 and 2010 if the water demand is 150 LPCD, that means 150 liter per capita per day. If one person use 150 liter per day, then what is to be the amount of water in 2000 and 2010? Let's see the solution. At first we set up year. successively 1950, 60, 70, 80, 90. Now we have designated this year by X, and we have find out first of all the middle year. Number of year here is 5, so middle one is 1970. You have to set up for 1970 is equals to 0. If we go back, then that is to be -1, and the uh, upper one is to be -2. And here the important thing is that the gap of year is 10, 50 to 60, 60 to 70. So successively, if 1970 is 0, then what would be the 1980? Obviously 1, and for 1990 it is to be 2, and the sum of x is equals to 0. Now y is to be the population of the particular year. What was the population of 1950? 1950 was 200, so here is 200, and same for others. Now you have to find out x square. -2x square means 4, 1, 1, 0, 0, 1, 1, 2 square means 4. X cube, same way you can find out the value of x cube. -2 cube means -8, -1 cube means 1. And the same way, summation of x cube is equals to 0, and here summation of x square is equals to 10. And the same way you have to find out the value of x to the power 4. And also summation of x to the power 4 is equals to here 34, and you have to find out xy, that means x multiply with y. So for first one it would be -400, here is -400, and same for all. Summation of xy is equals to 620, and another value is to find out x square y. X square means 4, y means 200, that is 800, and the summation of x square y is equals to 3180. Let's see the remaining part. In the above table, 1970 has been taken as base year, and a decade has been taken as 1 unit in x coordinate to eliminate some of the terms and make the consumption similar, as I discussed previously. Now we have to use 3 equations. Here is the basic equation: summation of y is equals to na plus summation of xb plus summation of x square c. This is the equation number 1. Equation number 2 is equals to summation of xy is equals to summation of xa, summation of x square b plus summation of x cube c. And the last one is summation of x square y is equals to summation of x square a plus summation of x cube b plus summation of x to the power 4 c. Now we have to put the value of summation of y. If we go previous slide, then you have to find that the summation of y is equals to 1510. N means number of years. There are 5 numbers of years, so n is equals to 5. The value of a is equals to a. Summation of x is equals to 0, so summation of x is equals to 0 multiply with b is equals to 0. Summation of x square is equals to 10 and multiply with c. Similarly, summation of x y is equals to 620. Summation of x is equals to 0, so here is to be 0. Summation of x square 10, 10 multiply with b, that is 10b. Summation of x cube is equals to 0, so multiply with c means 0. And the last one is summation of x square y is equals to 3180. Summation of x square is equals to 10, that is 10a. Summation of x cube is equals to 0, that is 0 multiply with b means 0. And summation of x to the power 4 is equals to 34, that is 34 multiply with c, we get 34c. Now if we solve these three equations simultaneously, then we get the value of A, B and C. And by solving this equation, we can find out the value of A is equals to 279.14, B is equals to 62 and C is equals to 11.43. Now one question may come to you, how we can solve this equation easily. You can use your calculator, three equation here. So by using your calculator, you can easily find out the value of A, B and C. Now the equation fitting the population data is given by y is equals to A plus bx plus c x square. Now if you input the value of A, B, C in this equation, then you get y is equals to 279.14 plus 62x plus 11.43 x square. Now you have to find out the value for 2000. 2000 means the value of x is equals to 3. Why 3? Because 1990 was 2. So obviously 2000 would be 3. That means the value of x for 2000 would be 3. So if you input the value of x is equals to 3 in this equation, then you can easily get the number of population for 2000. So the number of population is to be 568, and we have previously seen that the water demand was 150 LPCD, that means 150 liter per capita per day. So for 568 population, the quantity of water is to be 568 multiplied with 150, that is 85,200 liter per day. Similarly, for 2010, the value of x is to be 4 here. If you input the value of x in this equation is equals to 4, the value of x is equals to 4, then you will get the number of population for 2010, and it would be 710. So the quantity of water is 700 multiplied with 150, that is 1,06,500 liter per day. So it's all about our water demand lecture. Today is no more. Stay safe. Thank you.